Hello, today I will explain basic things that you need to know when building your robot, because usually you start building a basic robot like this one. It's a basic robot, just primitives. And other times, like this time, you will start with a very complex robot with meshes and physics built in. So depending of the drawback that you want, if you want to the robot looks nice, then you have to construct the robot with meshes. And if you want speed or just test your algorithms, you only need to construct a primitive for a robot. It depends of the kind of application you want to develop. Usually we start with another robot with meshes because we want to look and feel like the robot in field. So I will not explain everything. Everything is on the ROS wiki, but the basic things. The first thing that you need to know is what are the links and joins, and what are parent and child. When you start using URDF, you have to define your robot. Practically have those things to construct them. On the ROS wiki, you will see this thing. Let's see. Okay. The joins are the union between the child and the parent. Child is obviously predecessor of the parent, and there are also links. Let me see something. Okay, the links is the whole. Let's say the head of the robot, the body, everything is a link. So the union between links are the joints. Told that, let's move to an example. Suppose we want to put the head of the R2D2 robot. Those files are from the ROS wiki. There are tutorials about URDF. There are tutorials about Sacra. We just explain the basic because we want to go faster and move, understand what I put the tool in the Sacra file in that way. So first thing, we can define a head. I will copy and paste to go faster. So usually when you have another one, you put the link and the name of the link. You put some. This is the basic stuff. You put on the visual. You have to specify which type of geometry. In this case, we are putting the head, so a sphere is more appropriate. The origin, obviously, if we want the position and the orientation, we have to define it here. If we put 0, 0, 0, that is the default, will be on the center of the body in the main joint. Usually is in the depending of where was the joint defined, it will be tied to that part. So when we put it here, obviously we don't see anything. If we can offset it a little bit, let's say 0.5, now you see the this fur. We can 125, 130, 0.4, 0.35. Okay, that's okay. Okay, now we have this thing. It looks okay, but when you go to RVs, you will see that there is no TF associated to the robot. There are several steps I'm not explaining because when you do the launch file, you put the joint state and you publish the joint states. But for publishing the joint state, you have to put a joint. So we have to put a joint here or here, let's say. So let's name it base to head, type fixed. On the ROS example, you will see that it is revolute, but just for making it simple, we will put it fixed. There's several types. I think revolute, continuous, fixed, and there's another one, I think. The next thing is to specify the parent. Usually is the previous link, and the child is the current link. If we leave the origin, you will see that there is an offset here with this offset added. So look at this. Okay, we'll see that the offsets are added. So for stay on the same position, because this is the default origin of the link, but when we attach to the base link, in this case the origin, that is the blue cylinder, will offset this position plus this position, and also if we specify the roll pitch yaw here plus the roll pitch yaw here, it will be a little mess. So that's the first thing that you need to know, how to link different types of how to attach different type of links to the joints. To all that, let me move this to the original. Okay, to all that, let's move here. Okay. So there is a problem here. I didn't display correctly the robotic arm. Probably is something related to the extension, and I'm not running on a local Linux machine, just a virtual machine. So this is the original file that is over. Initially, there's no file related to the tool. Usually, when you get a robotic arm, you will see that there is no tool attached, because that's the end of the that's what we need to add. Usually, we probably a sucking pump as a tool, or a gripper of 2 fingers, 3 fingers, anything. So for attaching the gripper, we first need to include the gripper file that is located here. I got it here. This is the gripper file. Okay, there is a lot of information here, and the basic things that we need to know is that here we call the gripper using a macro. A macro is like a function, to simplify things, that has some parameters. You look at it here, we have a parameter called prefix that is located in front of the links, a parameter named parent that is from the parent link. It will define the parent link, and start parameter named origin. I will explain it. So let me charge it. Okay. From the ROS wiki, okay, we can use macros that are specific function. So you see here that macro has a name and its parameters. It could be simple, star, or double star. And what does that mean? Well, that's just a parameter. For example, the first one, that is suffix, that's a parameter that will be used to make a string here. For example, it will be if the parameter instantiate is front left, so the name will be PR2 caster, and the suffix will be front left. So will be PR2 caster underscore, sorry, the link name will be caster underscore front left, and so on. What happens with the origin or the content or the another content? Let's focus just only on this one, because that's the one that we have on the macro that is related to the ARM. This defines insert block. Where is the insert block? insert block here. So we'll define the insert block name origin. It could be any name. That's the name of the insert block that will be specifying. So when we call suffix, it will put the string here. But when we call the start name origin on the name content dot start and another content, they are calling to insert blocks. Insert blocks are tags or XML data that you will position in this related space. So usually you specify the parameters with a descriptive name. It doesn't mean that it could not be any other name. For example, it could be org, and here you have to put org. And that's what they are using here. So the sacro macro use the name R2 gripper, the prefix. We will put anything. In this case, I think I put nothing here. It's a blank string. The parent will be, I think, the base link or something like this. No, sorry. The parent will be the n effector link. We will see later why. And the origin, usually you can put here the pose or the origin of the tag origin that is related to the URDF. So over here. So I call this macro R2 gripper. We'll see the macro name is R2 RG2 underscore gripper, sorry. RG2 underscore gripper. The prefix is the RG2 gripper. So I use the prefix RG2 gripper just to identify it here. And the parent link is the EE link. How did I know? Because I inspect the URL sacro of the arm and I check they have the EE link. We have to be very careful because if we specify a prefix here for the arm, so the arm doesn't have a prefix here, we have to put the prefix on the baseline. For example, if I put here UR3, I have to put here UR3 EE link. So that's not the case. That's why I put it simple. The prefix will be populated on the UR3 robot, and I have to specify the prefix here. Prefix, okay. I think you can use tool 0 because tool 0 is another link name, but tool 0. So tool 0. Yeah, sure. I think you can use tool 0, but usually you attach everything to the n effector link. Sometimes the manufacturers use this name or tool 0, depends. I don't know. So next, as I told you, you have to put the insert block. It's mandatory. It needs to have the insert block. In this case, is the tag name origin. We'll have a raw pitch yaw value, and you have the XYZ value. That's why I had to include the gripper, and I had to attach the gripper with a prefix named RG2 gripper. That is a descriptive name only, attached to the parent link, and put the origin as the default points. So when you load the movie package, you will see that it moves. Sorry, it will load it with the tool, but without those lines, it will not load with the tool. So everything. You need to know how to attach uh, links to joins and how to specify it on the Sacro file. Hope is very descriptive and very fast for you to understand how to do that. And that's all. Uh, Thanks for watching.